Okay, welcome again. Hopefully you've watched the last video and you've looked at how we work out relative molecular mass. What we're going to do now is we're going to look at how we use the chemical formula to work out the percentage by mass of a particular atom or element in that compound. So let's look at some. Let's go straight in and look at the equation we're going to need for this. So what I'm actually going to do then is, if we are looking at the percent by mass, then what we need is from the formula, we need to know what the AR total is divided by the MR times by 100%. Now, I've not really talked about AR and MR, but I just haven't called them that. The AR is the relative atomic mass, and the MR is the relative molecular or formula mass. The other thing that is worth noting here is that I've got the total here. And we'll come back to this in one of the examples, but there might be more than one atom of that element in the formula. Okay, so we're going to use that now, and we're going to go straight in to an example. So the example I'm going to use is lithium fluoride. Okay, let's go back to our blank. So if we got lithium fluoride, and I'm hoping that, having watched the last video, you'd know that we can add up the atomic masses of each of these. So lithium is 7 and fluorine is 19. So we should then be able to add those up, and we get a wonderful MR or RMM or RFM. My pen doesn't like me today. Equals 26. If we're then looking at the percentage of fluorine, if we want to know the percent of fluorine in lithium fluoride, then we need to do the MR or the AR divided by the MR, which equals 19 divided by 26 times by 100%. Then we work out that that equals 73%. So 73% of the mass of lithium fluoride is actually down to the fluorine in the molecule. If we look at something else then, and we're going to look at ethene now, so C2H4, the RMM equals 28, and I'll leave you to work out how we actually do that. If we want to know the percent of hydrogen in there, so percent H in C2H4, this then is 4 times 1, And this is where we come back to that total, because we have 4 there. The 1 is the AR of hydrogen, divided by then 28. So 4 divided by 28, let me just check my maths here, 4 divided by 28 is 14.2%. So, excuse me, so 14% or so of the total mass of ethene is due to the hydrogen. I'm going to do one more example before we go on to something a little bit more. Okay, so again, I'm going to use zinc cyanide. Okay, and this is a little bit more complicated again, because we need to know the molecular mass of zinc cyanide. So the RMM equals 117. If I want to know the percent of carbon in zinc cyanide, then I need to know that what we have is we've got this section here, and this means we have 2 times carbons, and the atomic mass of carbon is 12, but there's 2 of them, so it's 24 divided by the molecular mass of 117 times 100%, and that equals then 20.5%. And we're going to have lots of practice at doing this. What I'm going to move on to now is a different way of questioning these, and I'm going to type these questions out because it's probably a little bit quicker, and you'll be able to read it easier than my handwriting. So if I then go, okay, fantastic. If I've got a question such as how much calcium could I extract or get hold of from 100 grams of calcium chloride? How would we go about doing this? Well, first of all, we need to know what the molecular mass of calcium chloride is. And calcium chloride then has an RMM of 111. The AR, the relative atomic mass of calcium, equals 40. Therefore, percent by mass of calcium in calcium chloride is 40 divided by 111 times by 100%, and that comes out as 36%. But the question doesn't ask what the percentage by mass of calcium is. It asks how much could I extract from 100 grams of calcium chloride. So essentially then, if I have 100 grams of calcium chloride, 36% of it is going to be calcium. So we can then go, right, what is 36% of 100 grams? And I've made this easy on purpose. 36%. grams. So if you had 100 grams of calcium chloride, you would be able to get 36 grams of calcium from it. But what about if it didn't ask for something as easy as 100 grams? What if it asked for 26 grams? What about 26 grams of calcium chloride? Well, you could do the same sort of stuff. What is 36% of 26 grams? And you'll find that that equals 9.36 grams. So I go 0.36, or you can go 36 divided by 100 times by 26, and these are then the same. And then we get 9.36 grams. The other way to do it would be, well, okay, the RMM of calcium chloride equals 111. Therefore, 111 grams of calcium chloride contains 40 grams of calcium. 111 grams divided by 111 equals 1 gram of calcium chloride contains 40 divided by 111. All I've done here is I've divided both sides of the equation by 111. So that would give you how much calcium chloride you could extract from 1 gram, and then you times that by 26, and that also comes out as 9.36 grams. Okay, so that's fine. And you'll have more practice of that. If, though, I was to ask you, again, this keeps on coming up. I'll have to work out how to stop that coming up. If I've got another equation, and if I've got potassium nitrate, KNO3, if I work out then that the RMM of potassium nitrate is 101, I can then work out, I'm not going to go through the maths again, that the percentage of potassium in here is 38.6%. That tells me that in 101 grams, I've got 38.6 grams of potassium. If I've got 101 kilograms, I've got 38.6 kilograms of potassium. If I've got 101 tons of potassium nitrate, I've got 38.6 tons of potassium. Notice that we can use this so that look at what the units in the question are, so that you can match your answer with the same units. I hope you've understood what we've been through, and as part of a test for that, if you would now like to try the questions on the rest of the form, please. Thank you.